Picture yourself going to an unfamiliar supermarket for the first time. If you're a person who can see, you can simply look around to guide yourself and identify objects and obstacles. However, blind people must use other senses to find their way through a new space. Soon, the blind might have some navigational help, thanks to Caltech researchers who have combined augmented reality hardware and computer vision algorithms to develop software that enables objects to talk. Worn as a portable headset, the technology translates the optical world into plain English audio. The device could one day be made available in banks, grocery stores, museums, and other locations to help blind people make their way through unfamiliar spaces. The team of scientists developed a system they call Kara, or the Cognitive Augmented Reality Assistant. Kara was developed for a wearable headset called HoloLens by Microsoft that can scan a user's environment and identify individual objects such as a laptop or a table. With Kara, each object in the environment is given a voice and will say its name upon the user's command. The technology utilizes so-called spatialized sound, which causes objects to sound different depending on their location within a room. If the object is, for example, far to the left of the user, its voice will sound like it is coming from the left. Additionally, the closer the object is, the higher the pitch of the voice is. To avoid an avalanche of objects speaking at once, the researchers programmed Kara with several different modes. In the first, called Spotlight mode, the object only says its name when the user is facing it directly. As the user turns their head to face various objects, the objects each say their name, and the pitch of the object's voice provides an auditory cue about its relative distance from the user. In this way, a vision-impaired user can look around to explore their environment. In a second mode, called Scan mode, the environment is scanned from left to right, with objects saying their names accordingly. The third mode is Target mode, where the user can select one of the objects to talk exclusively to and use that as a guide to navigate. To test Kara's practical applications, the researchers designed a test route for blind volunteers through the Beckman Behavioral Biology building at Caltech. To prepare the task, the scientists first developed a route through the building and followed it while wearing the HoloLens, which scanned the environment and saved it to memory. Then the blind volunteers were asked to navigate the same route using Kara as a guide. Led by Kara, all 7 of the volunteers completed the task successfully on their very first try. Kara is still in its early stages, but will benefit from the rapid development of algorithms for computer vision. The researchers are already implementing new schemes for real-life identification of objects and pedestrians. Eventually, they hope that places like banks, hotels, and shopping malls will offer Kara devices for use by their blind customers. In addition to their work with Kara, the team also developed a new standardized test to evaluate the performance of various assistive devices for the blind. The method provides a virtual reality environment that researchers anywhere in the world can use to benchmark their devices without having to reconstruct real physical spaces.